Today we are going to learn about one of the most interesting topics in science, the periodic table. These are the things that we will learn about throughout the video. You can go through them. Classification of elements. We know that there are more than 118 elements that are known to the scientific world. In the earlier days, when there were fewer elements, to be precise, around 30 elements were found. Scientists found it very difficult to organize them without a proper classification. Hence, to make things easier for them as well as the people learning about the elements, the first idea of the classification was to classify the elements into metals and non-metals. Therefore, they started arranging them in a table. But as the knowledge of the elements increased, we started seeing new elements, and this classification was not enough, and hence new types of classification were introduced. We will have a look at all such classifications further. These are some of the most notable and most important famous classifications: Dobryn's triads, Newland's law of octaves, Mendeleev's periodic table, and the modern periodic table. The Dobryn's triads. This was one of the oldest and first classification of elements in the year 1817. A German scientist, Dobrynner, said that the properties of elements are related to their atomic masses. He basically arranged the elements according to their atomic masses and then classified these elements into groups. Each group had three elements, and these elements also had similar chemical properties. These elements were called triads. He arranged three elements in a triad in increasing order of atomic mass and showed that the atomic mass of the middle element was approximately equal to the average of the atomic masses of the other two elements. But the question here was, why wasn't this accepted? The answer to this question is that the theory was not true for all elements, hence this method of classification was not accepted worldwide. So as you can see, this is an example of a triad by Dobrynner. So lithium, sodium and potassium were in a triad, and the average of lithium and potassium gives you the actual atomic mass of sodium, and that's how triads were arranged. Here you can find these questions. Try solving it yourself. The answers will be revealed in the end of this video. The next type of classification is the Newland's law of octaves. In this classification, scientist John Newlands in the year 1866 arranged the elements known at that time in an increasing order of atomic masses. So basically, he started off with the lightest element, that was hydrogen, and ended up with the heaviest element, that was thorium. He arranged these elements in series of 8. He found out that every eighth element had properties that were identical to those of the first. So every eighth element was a repetition of the first element. For example, sodium is the eighth element from lithium and both have similar properties. Again, magnesium shows similar properties to beryllium and chlorine shows similar properties to fluorine. He compared this similarity with the octaves in music, like sa re ga ma pa dha ni sa. You can observe that the eighth note is similar to the first. Hence, this method was called the Newland's law of octaves. So the problem with this classification was that the idea of repetition of the first and eighth element properties was only seen up to calcium. So the elements after calcium did not show repeating properties after every eighth elements. Another problem was that during Newland's law of octaves, when it was discovered, only 56 elements existed in the nature and no new elements were discovered by then. So he did not leave space for any new elements that could be discovered in the future. But later on, as elements were discovered, the properties did not fit into the octave. So he put elements of different properties in one slot, for example, cobalt and nickel, but it wasn't possible for it to be feasible because they didn't have the same properties. So these were the limitations of the Newland law of octaves. Here you can find some more questions to solve and the answers will be revealed by the end of this video. So moving on to Mendeleev's periodic table. In the year 1869, Dmitri Mendeleev arranged elements that were known by then in a periodic table according to their atomic masses, so increasing order of the atomic masses, and his periodic law stated that the properties of elements are periodic functions of the atomic masses. So according to this and the basis of chemical and physical properties of elements, he arranged a periodic table in an increasing order of atomic masses. And he also noticed that there was a repetition of properties after every eighth element. So that was there as well. So, in his periodic table, the horizontal rows were called periods and the columns were called groups. So, there were 18 groups in total and 7 periods. Here you can find the Mendeleev's periodic table and look at the arrangement of how it was formed, and you also notice the empty spaces that are there for the elements that were not discovered till then. So coming to the merits and demerits of the Mendeleev's periodic table, the first merit was the atomic masses, which were initially wrong, that were predicted before, were researched, looked into and revised by Mendeleev so that they could have a proper place in the periodic table according to their specific properties. And also, like I mentioned in the previous slide, he also left vacant spaces in the periodic table, keeping in mind that the new elements will be discovered in the coming future. Another merit was that he predicted properties of undiscovered elements, which was helpful for the elements in the future and made classification easier. He called them Eka, so it was Eka silicon or Eka boron. And he also made a specific zero group for noble gases that were not discovered by then, and all of them fit in the zero group. Some of his demerits were that hydrogen did not have a fixed place in his periodic table, and also by the time he was he had discovered the periodic table, isotopes were not discovered, so there was no place for isotopes and he could not explain the position of isotopes. Also, there was ambiguity regarding the sequence of elements. For example, cobalt and nickel had atomic mass nearly the same, so with a point difference, so they did not know where to place cobalt and nickel, like before or after each other. Another such difficulty was that he did not know how many elements could be discovered in between two elements, because they increased in atomic mass, right, but they did not increase accordingly. Like it was not a fixed number of grams in which the increase was seen in, so it was very hard to predict how many of elements could be discovered in between two elements that were already known. And that's why his method did not was widely accepted, because there were certain elements, rare earth metals and isotopes, that did not have a place. Here you can find some more questions to answer and you can look at the answers in the end. So coming to the modern periodic table. So the modern periodic table was created by scientist Henry Moseley in the year 1913. He did an experiment on the frequencies of X-rays and came to the conclusion that atomic number is the fundamental property of an element. So arrangement of elements in this periodic table is based on the modern periodic law that states that the physical and chemical properties of elements are the periodic functions of their atomic masses or atomic number. So basically what this means is that the periodic table is based on basic fundamental property of atomic mass or atomic number of an element. So here you can see the modern periodic table, which consists of a total of 180 elements that are known up to date. These consist of alkali metals, alkaline earth metals, transition metals, heavy metals, weak metals, metalloids, non-metals, halogens and noble gases. So the modern periodic table, like that of Mendeleev, consists of groups and periods. So there are 18 vertical columns called groups starting from 1 to 18. The element in each group have the same outer electronic configuration and hence have similar properties. Group 12, 13 and 17 are called normal elements. Group 3 to 12 are called transition elements, and group 18 consists of noble or inert gases. So the horizontal rows in the periodic table are called as periods, and there are 7 periods in the periodic table numbered from 1 to 7 top to bottom. Each period begins with an element having 1 electron in its outermost shell and ends with 0 group element having a complete outer electronic configuration, that is 8. The transition from a metallic to non-metallic characters seen across a period for the first period only consists of 2 elements, hydrogen and helium, while the second and third period consist of the 8 elements each. Fourth and fifth period consist of 18 elements. On the other hand, the sixth and seventh period consist of 32 elements. The bottom separate panel consists of 14 elements of the sixth period called lanthanides and 14 elements of the seventh period called the actinides. They are known as the lanthanide series and consist of rare earth metals, and the actinide series consist of radioactive elements. Each period represents the number of shells or energy levels present in the atom of an element. So here is the last set of questions that you need to solve before looking at the answers. And here are your answers that were asked, like for the questions that were asked overall in this video. Please do solve it first before checking these, and if it's wrong, do check again. I hope you had a great time listening to the video and you learned something about the periodic table. Thank you.